So here we go. We're going live, so keep it to a minimum. So we couldn't even satisfy A with this, right? Because we can't have 0 as a denominator. So at this point, if we had put this into the calculator, we would see that there are 2 different asymptotes.
Would you just get a divide by 0?
No, you could graph it, because if you put it in a 1, you get out a value, right?
Oh, I thought you meant
So if you put this function into the calculator, you get 2 different asymptotes.
I thought you meant with negative 2 already.
It's here. I'll show you on the calculator. If I go to y equals and fix this one, minus 8 and x squared. What is it? Minus 4. Minus 4.
Yep.
Close the parentheses, and then graph.
Yeah, it's an interesting one.
So what you get
2 lines.
is an asymptote here at -2, and you get an asymptote here at 2. And what you get?
I got like a double one.
Yeah. Oh, so your window needs to be shifted over.
Oh.
What you get when you see this is
Well, shouldn't it be centered on negative
you get
2?
this weird kind of a parabola, but it's going to be straight up and down.
Oh, there we go.
And I think it goes down, right?
I'm sure.
Where is this? Let me see. That's right. Dude, what are you doing? What'd you do?
It was just there.
I just spelled Desmos with an extra O.
100. It goes like this. So there's an asymptote here at -2 and another one here at 2 that the line can never touch. The graph can never touch those points, right? The truth of the matter is there is value in here that doesn't exist either, right? So it's not a big deal.
Oh, that's a funky graph.
That's a nice graph, right?
It's
Let's see stuff like this. We won't do a lot of analyzation with stuff like this. We'll do the continuity rules for stuff like this. We won't do a lot of graphing because we don't want to worry about that in these graphs. But let's move on, right? Do you remember what a limit is? A limit do you remember?
What?
A limit.
The point on the function that you can't have, but you want to get infinitely close to.
We're trying to get the y value that we're getting infinitely close to at some value of x.
What is this?
That's not a graph. Close it up.
It's so broken.
Sir, I changed out the squared in the bottom of the fraction for
2.
fourth power, and it
goes wicked, right?
the bottom 2 are the same, but like the parabola is like it's off.
It's like angled down. It's
Like there's it's
like
a bit like a oopsies.
Yeah, so it's got a little W to it. It's like this parabola becomes something like that.
Except I think
It's a little flatter than I just made
the
it.
middle bump is so small.
It's a
you
little
don't
flatter.
even really notice it.
That's the idea.
It's very shallow.
Okay. Yay. So limit.
Graphing is fun.
And the only thing we use limits for at this point in time is end behavior. That's all. Right? So continuity, we understand. Is this continuous? Is this graph continuous at this point here? No. What kind of discontinuity is it? It's an infinite discontinuity, right? And I don't know if they mentioned that, but that's what it is. Infinite, yeah. They did write that down. Right? Why? Because it never, ever comes in contact with that. That space at -2 doesn't exist on the graph. Okay? And you see it by this jump. This, if we wanted to talk about just this guy right here, what are we looking at? We're looking at it going infinitely down and infinitely up at the same time. From the left side, we're going down infinitely, and we never get there, right? On this side, we're going up infinitely, so we have an infinite discontinuity. Now, I'm going to do something easy. Want to do easy first?
Sure.
Let's talk about end behavior. If you want to use Desmos, if you want to use your calculators, let's graph something real easy. Ready for the fun? Woohoo! It's math.
I'm so excited.
Let's talk about a parent function. We haven't learned about parent functions yet, but let's talk about f of x equals x squared. Cool? Easy, right?
Pretty easy.
You know where this is going to be on the graph. You know full well because you have graphed this a million times. You put in 0, you get out 0. That's our vertex. Right?
I
And you
think
just
you
got
got either
a
that or
parabola.
the window isn't centered.
right there. Sound good? We've
Which
seen
one
this.
is window.
A bunch.
Window.
Now.
Window.
If I said, is this function continuous at x equals -2? Is it continuous at x equals -2?
Yes.
Yeah, absolutely. Right? Because if I'm over here at -2, right? 1, 2, 3, 4, right? Basically,
There you go.
right? We got -2, +4 as our point there. So we put in a -2, we get out our 4. We say, great. Are we approaching 4 from the left and the right? Yeah. Yeah. The line approaches it from both sides. Absolutely. So the limit does exist. And it's a real number. And if both of those are true, then C is true. And we have a limit. It is continuous at that point. Good? Great. So now that's all done. Let's talk about end behavior. What do you think we're talking about when we're talking about end behavior?
Where the line goes or where the problem goes.
Where those arrows are pointing, basically, right? Those are the ends of the parabola. And they're both pointing up infinitely, right? So if I wanted to talk about the end behavior of this function, the end behavior in interval notation would be -infinity to +infinity.
How is it negative?
Oh, geez, positive.
Zero.
Oh, both ends go up, right? Oh, I did it wrong. That's why I was going back in time. I was in a time machine. Did you see it? I meant to do this. F of x, right? The limit of f of x as x approaches negative infinity. I just talked about limits and I forgot to write the limit notation. Thanks for catching me. Is infinity, it goes up infinitely.
That's how we have to.
That's how we list end behavior. I apologize for having a brain fart there. So as we go farther and farther left, we go higher and higher. Well, that looks right. So the limit of this function, as x approaches infinity, goes farther and farther and farther to the right, is also infinite, right? Both ends are pointing up, so our end behavior is infinite. Easy? Yeah. Ah, easy. Yeah.
The first one is negative infinity.
So here,
Yeah.
as we approach, as x goes farther and farther to the left,
Okay.
as the x value goes farther and farther and farther to the left, we go higher and higher and higher on that board. Same thing as if we go farther and farther to the right. All right, ready for another easy one? Sure. Good. What if what do you miss? What's wrong?
It's obvious.
Oh my gosh, is it that time? Is it 1:15 already?
Yes, it is.
Holy moly, it's 1:15. If you need to go use the latrine.
I see you were highly focused.
He was asleep. Are you kidding?
No, that was a joke.
That's all right. I'll post this. You get your homework.
I'm equal for me.
If you put, yeah, absolutely. Have fun out there. Hey, you're gonna have fun no matter what.
Yes, sir.
Bray,
At least don't
Fun.
embarrass yourselves.
okay? Randy's Randy. He's a sieve
A sieve is crazy, sir.
as a goalie.
I know what you mean, sir.
Okay.
Oh, who's love from?
The limit of this function as x approaches negative infinity, as we go farther and farther left, what's happening to this function? Going down. The limit of this function, thank you, Mr. Berry. Don't think I'm ignoring you.
I don't think you will.
I'm having a weird day, dude. As we go farther and farther right, what's happening on this function?
It's going up infinitely.
So this is your big moment, right? Even, odd. That's all it is. So this is an even function. Both ends point in the same direction. Odd function, different direction. That's all. And you knew the most famous of all odd functions, right?
The straight line.
So we'll start watching the movies.
Wherein M equals
Back to basics.
anything positive and B equals
Right.
anything.
Well, it could be, yeah, it has to be positive, or it could be negative, right?
Sorry.
Still an odd function, both ends point in opposite directions. You've been working with both even and odd functions for a long time now. We just never told you what they were, because you never had to analyze it in that fashion. Cool? Yeah.
I was listening. I was applying the odd function.
Say it again.
I was applying the odd function.
An odd function,
Yeah.
because this exponent here, what's this exponent here?
What?
1. Odd or even?
Oh,
Duh. Now, are we always going to have easy functions? Look at that crazy, crazy, crazy piece in number 2 at the bottom of the page. Look at that sucker, right? It's got that asymptote, doesn't it? So there are ways to find if a function is even or odd. It's just we don't need to know it at the moment. We just want to look at end behavior, right? Now, if it has an asymptote, we have to show that break, right? So from here to here, what are the ends doing? Well, we don't care about this. Isn't that awful? When we're only talking about end behaviors, we're talking about when we go out infinitely. We don't care about the middle. We'll be able to list what happens in there. But when we're talking about end behaviors, the limit of number 2, as we go farther and farther and farther, farther and farther and farther to your left, it looks like we're getting infinitely close, right, to 5. We're getting really, really, really close to 5. Let's doing the same thing on the other side, because there's an asymptote at 5. So if you can see that there's an asymptote at 5, or if you look at your calculator and you get to 5, or you get to everything getting super, 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 super close to the value of 5 as it goes up or as it goes down, you can tell that there's an asymptote. So I'm going to ask you to do one thing first. Now, number 1, we understand how to list that end behavior, right? You're looking at number 1? Number 1 is quartile, right? Negative and quartile. Looks something like this. And it's negative 4x to the 4th. Is it really 4x to the 4th? No, it's just negative x to the 4th. That'd be really steep. Negative x to the 4th minus what? Minus 2x. This minus 2x is what gives us that little bump there, that little dip in there. Cool. And I did it wrong because it should, because there's no constant, our y-intercept is 0, so it should cross through the origin. Should cross through the origin. All right. Even or odd function?
Even.
Even, right? They point in the same direction. Positive or negative?
Negative.
Negative. It's pointing down. See how easy this is? Even you guys can do it. Even you can do it, Michael. So as we go farther and farther and farther to the left, what's happening on this end?
It's going down.
It's going down. So instead of infinity, we're going to write. As we go farther and farther and farther to the right, same thing. Both ends are the same. That's it. If we're only looking at end behaviors, and that's what it says, use each graph to describe its end behavior. Support it numerically. Really? Okay. If I put in negative 4 billion, I'll get something really, 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 really low. Right? And if I put in 4 billion, I'll still get something really, really, really low. Why? Because this bad boy right here is gonna make it low. And this is gonna make it even lower. Does that make sense? I know that sounds dumb. But you could, if I needed you to prove it, you could put in a 3, right?
We should put it like before numbers, like just to see how it looks.
2, yeah. Right? What's 2 to the 4th? 16, right? So we have negative 16 minus 4, that's negative 20. So we are going down. And we're also going down on the other side. We put it in a positive. Yeah, absolutely. Yeah, I don't want you to put 4 billion in, that'd be ridiculous.
But it'd be fun.
Yes, Mr. Soba wants to destroy your life. That's what calculated.
Manually calculated.
Yes, please. Do it by hand.
Down to 9 digits.
Well, think about it though. It would be pretty easy.
Oh yeah, long
16,
division and
16
multiplication by hand is
with
the hardest,
18
just takes a long
zeros?
time.
Right? Isn't
Exactly.
that the point? So, 1.6 to the, what, 19? 10 times 10 to the 19? I think we could do that. You guys know scientific notation, don't you?
No, I think so.
I would get you there. It wouldn't be a big deal. Easy stuff? We're okay?
Yes, sir. That's it.
Nice.
I don't know why it's so strong.
And scene. At least he's laughing. Oh, God. I thought I got some awful email. Nothing. Sorry about my phone. I was just trying to check the time. We have plenty of time. Is it okay if I give you easy work to do?
Sure.
No.
Sure. Will my grade go up?
Your grade will continue to be good, yes. Is your grade bad right now?
Hope not.
I hope not. Have you turned everything in that you're supposed to turn in?
I think I have this one homework assignment, which I'm hoping I can make up or something.
We'll find out what it is and we'll make sure you get it in.
I got 2.
Woo. No.
Oh, okay.
2 pages, give it back to him. Give it back to him. I handed him 2 pages for a reason.
What the hell, Suit? Kick him out.
I'm about to hand you 2 pages, dude.
Class and the school.
Hand it back to him.
Get him going.
No. Give it to Malik.
Oh.
Yo, what's
And see. Look at how simple this. Oh, I just kicked the camera.
I made something fun in Desmos, sir.
What did you do? Oh, you're just drawing function?
So,
You're
sir,
drawing some creepy
you
function?
see the blue and black lines?
Oh, nice.
They never touch. The blue and red line never touch.
Wow.
They keep getting closer, but I've scrolled it out to the thousands and checked they don't.
Oh my gosh.
I say you're wrong.
You write beautifully. It has nothing to do with mathematics. But you write beautifully.
Good handwriting. He actually
Holy
stays in the lines.
Holy, Mr. Joe.
Can I have your hand?
Feel free to join.
I could never.
Right? Because if we do this
My handwriting.
and we get through this,
It's legible.
you'll be done with your homework, right? So I want you to, oh, look at this one. Oh my gosh. That's cool. Postcards?
I do love just putting in random functions.
All right, so If we look at number one, do number one together. Number one is a function. Nice parabola. The function is. Sorry. The function is. I know. Come on, take it too long. You old fart. I heard that, Maroni.
So,
I wouldn't blame you. I'm old. I'm older than your dad.
how old is that?
60.
For real?
Yeah.
He's older than I am. He looks a lot better than I do. That's pretty good.
He takes
Which
personal
he takes
help.
excellent care of himself. Tell him I said so. Tell him I'm totally impressed. I'm 58 and I'm an old fart.
I think it's just genetics. Really. My granddad was.
I'm having fun too. I have a great. I'm the luckiest guy in the world.
Never shame your body.
Most of my family doesn't look
this
particularly
thing?
young, but they
Too
live
late.
a long time.
Now, we obviously see this as a parabola, right?
Yeah.
And we see that it's continuous at that point, right? We're good.
Comes up to
We're
60.
okay. Cool.
How did you get 16?
One.
It should be -2.
I put it.
I think you put it in
Yeah,
wrong.
no.
You did. You made one little mistake.
You
Okay.
might be right.
You may be right. Okay. What we want to know is it continuous? Yes. Now, do I have to go through all the motions? Do I have to jump through every hoop? No. We see it. It's a parabola. We're good. Just write, sir, it's a parabola. It's continuous.
You're a little bit slow.
And then there are no discontinuities. The last thing I want you to do is tell me about end behavior. It doesn't talk about it here, but tell me about the end behaviors.
Write it in.
End behaviors. So I want you to write in limit notation. Okay? The limit of this function as x approaches negative infinity is, woo!
Hello notification.
Oh, that was Captain Bradley.
Oh.
And then the limit of this function
I like.
as x approaches infinity is the same. It's the same.
That's so cool, sir. I love math.
So the only thing it doesn't say on this paper is tell me what the end behavior is. And it would help me a great deal if you could write it in limit notation. That's all. Because if you could write it in limit notation, then when we start to work with limits at the end of the year, you'll go, oh, that garbage again.
Sure.
But you'll remember it. Yes. So we had to learn a little bit about limits to discuss end behavior and look at end behavior in terms of limit notation, but we're not going to spend a lot of time looking for limits. Okay? We're going to journey through limits to prep you for calculus at the end of the year. Yay! Predicting the future! You can be a
So
soothsayer.
knowing what's going to happen is boring. It's more fun to just test
Understanding
it and find
trend,
out.
right? When you go into business, it's good to understand trend, to understand functions, right?
Graphs.
Yeah. When you pull a bunch of data, if you're selling a product,
Stocks too.
absolutely. It's harder to predict stocks only because of how the market fluctuates due to politics as well as environmental ideas.
Yeah.
So it's tough. It's tough. Insider information is always good. So if you can be that guy, I know it's not necessarily legal, Oh, now I'm on video saying it, but I can't do it because I'm old and I don't have any money to invest, so I don't have any of that.
So,
But when you do, congratulations, you'll make boatloads of money.
we can start at $10.
You can, but you can't get much higher. Okay, so here's our
Infinite money.
There we go, really. Really.
Okay.
Walk up to an ATM. They don't know.
If we look at number 2, he said number 2. Gross. 2x if x is greater than 0, negative x squared if x is less than 0. Is this function continuous at this point?
Everyone, every single character.
A little steeper. Sorry, steeper. There we go.
Sorry.
Yes.
Is this, here's the axes.
Yes.
I know it's a dotted line, I just didn't want to draw through that circle. Is there a value here?
Yeah.
Where?
2x.
What part of the function does it work? We're talking about everything greater than 0. Are we including 0? Is there an equal sign there?
No.
Is there an equal sign there? It's a removable discontinuity. That hole right there, if you see a hole in the function and there's no other dot somewhere along the y-axis or above or below that hole, it means it's a removable discontinuity. We just took that point out. It doesn't exist at that one teeny tiny point. I know this circle is pretty big, but it's only at that one tiny point. Now, is there a limit at 0? Are we approaching from the left and from the right the same spot? Are we getting infinitely close to the same number from both sides? We are. So there is a limit. And the limit is 0. But there's no actual value. So it's not continuous, but there is a limit there. Too much? No. Are we okay? Perfect. Is everyone all right? Malik, are you still with me? Kind of, sort of.
It's from the left.
I know. Listen, I know you guys don't sleep.
I went to sleep.
I
at
need to do the
1:30.
best I
That's
can
pretty reasonable.
with what you got. Right?
So I didn't sleep during this class.
Slept
You,
during any of
my heart right now is so full because you have not nodded off a bit. Did you get some sleep this weekend for a change?
No, it's
Oh my God, sir.
He's just running on
Again?
caffeine, sir.
So you're just running on caffeine.
No, I didn't even drink any coffee. I don't know
Really?
why- I don't know why I'm awake today.
Listen, I couldn't be prouder. So while I got you, the limit of this function, Mr. Cho, as we go farther and farther and farther to the right. As we go farther and farther and farther to the right. To the right.
To the right.
Didn't I say negative infinity?
To the right.
As we go farther and farther and farther to the right. What's happening?
Down.
We're going down infinity. So we say it's negative infinity.
Sir, I think it's probably because I slept during first, second, and third.
Who do you have first, second, third?
Probably.
That would explain it.
Is Captain Han one of those teachers?
I don't have.
He would never sleep.
He
in
has
class, sir.
One of the most soothing voices. It would be, for me, it would be like nap time.
He like at
Tell
first,
me a story, Daddy.
he wakes
Like,
people.
the information that he gives you is so interesting,
It is.
but his voice is so soothing. Like mine is grating, it's a little too loud, a little too focused. He just tells you a story. I love it, I love it. So we have what looks like, it looks like it's an odd function, but is it? No. It's piecewise.
I think this makes sense.
Pretty cool, right? But it does have end behaviors, right? Cool? Almost.
Sir, I made a graph.
Your homework is giving
No
me
homework.
continuity on 3, 4, 5, and 6.
I tried, guys.
We'll do
There are-
7.
We don't have 5 and 6.